Let's have a look at question 8 in this video. So we still have the question with the lamp, which has a mean of 5,000 hours and a standard deviation of 300 hours. And we're looking for the so to check the quality of the lamp, somebody measures the lifetime for 9 lamps, and now the probability that the average lifetime for these 9 lamps is less than 4,850 hours is going to be the following: true or false. So what we're working with now is average. That's the keyword over here. So if we draw our distribution, with the mean of the lifetime of 5,000 hours, so this is our 5,000 hours, and we want to know the proportion that the specific average is going to be less than 4,850. We're looking for this proportion, but we're not looking for any lamp. We're looking for the average of a specific sample. So we're looking for the average of a specific sample with 9 observations, because we're taking 9 lamps. And recall that if we want to replicate this on the z distribution to work with actual probabilities, so if we do it over here right next to it with the z distribution that has a mean of 0, then what we're looking for the difference between that specific average. We're looking for the difference between that specific average from the population mean of 5,000 in terms of standard errors. So not in terms of standard deviations anymore, because the standard deviation is just for the population observations, but the standard error of the sample mean of 9 observations that we're looking. So the standard error is equal to the standard deviation divided by square root of n, which is equal to the standard deviation of 300 divided by square root of 9 observations, which is 300 divided by 3, and that's equal to 100. So the standard error is going to be equal to 100. Now we can calculate the z value over here. We can do it right below it. So the z value is equal to the difference between the average of 4,850, that's what we're interested in, minus the population mean of 5,000 hours relative to the standard error of 100. And if we work out the math here, that's going to be a z value of minus 1.5. So what we're interested in was the probability that the z value is going to be less than minus 1.5. We're looking for this area over here in the z distribution. So if we have a look in the z distribution, the probability that the z value is less than minus 1.5 is equal to 0.0668, which is approximately 0.067. So if we have a look at the answer key, the answer is 0.3085, and that's not the answer key, so it is false. And that's it, we are done.